Pick any whole number you like. Now follow 2 rules. If your number is even, cut it in half. If it's odd, triple it and add 1. Then repeat again and again. Here's the strange part. No matter which number you start with, you always eventually come crashing down to 1. Try it with anything. It works every single time. And yet, no human being on Earth has ever been able to prove that it always will. This is the Collatz conjecture. The rules are simple enough for a 6-year-old, and it has defeated every mathematician alive for nearly 90 years. Let's actually watch one. Start with 7. 7 is odd, so triple it and add 1, 22. 22 is even, cut it in half, 11. 11 is odd, so up to 34, then 17, then 52. And it keeps climbing and dropping, climbing and dropping. Mathematicians call these hailstone numbers because they bounce up and down inside the clouds, just like a hailstone before finally falling to the ground. And the ground here is always the same, the number 1. From 7, it takes 16 steps, but it gets there. Now you might think small numbers behave, and that's the trick, so let's try 27. It looks just as innocent, but 27 goes on a rampage. It climbs and climbs, soaring all the way up to 9,232, hundreds of times bigger than where it started. It looks like it's escaping to infinity. And then, after 111 wild steps, it collapses, right back down to 1. No matter how high a number flies, no matter how chaotic the path, every single one tested has come home to 1. So why can't anyone prove it? Here's the cruel part. The 2 rules are fighting each other. Tripling and adding 1 makes numbers explode upward, halving drags them back down. And which rule you hit next depends on whether the number is odd or even, which scrambles around with no pattern you can predict. It behaves like pure chaos, and yet it always, somehow, lands on 1. Mathematicians have checked every number up to 2 to the 68th power. That's about 295 quintillion, and not one has ever escaped. But we checked a lot of them is not a proof. To actually prove it, you'd have to show that every number out of infinitely many falls to 1. That none of them shoots off to infinity forever, and none get trapped in some other endless loop. The closest anyone has come is the mathematician Terence Tao, who in 2020 proved that almost all numbers eventually get small, almost all. It's a stunning result, and it still isn't the whole thing, because in mathematics, almost all is not the same as all. A single rogue number, somewhere out in the infinite, would break the whole conjecture. We have never found one. We also can't prove one doesn't exist. So that's 18, and for the first time in this whole series, something strange happened. Every other time, math crushed your intuition without breaking a sweat. But this time, math couldn't even beat itself. Erdős, one of the greatest mathematicians ever, looked at this problem and simply said, "Mathematics may not be ready for such problems." Brain, 0. Math, 17. And round 18, for now, nobody wins. The easiest looking question in math is still sitting there, unbeaten, waiting. Subscribe, the streak is linked from the start, and maybe, just maybe, you'll be the one who finally solves it.